Hello guys, welcome to In 5 Minutes. Today we will see the topic state machine. To understand a state machine, which is nothing but a sequential circuit, up till now we have seen counter as a sequential circuit. Counter, it counts the states. It has to retain in its state till it hits with the next clock cycle. Now see, there is a clock cycle which turns from state 1 to state 2 or to the different states. But state machine is a different kind of sequential circuit. To understand the state machine, you need to understand the example of traffic signal. Suppose the traffic signals turn green for 60 seconds. You can travel by that road till 60 seconds. Means what? The traffic signal in the green state, it will remain throughout the 60 seconds. Throughout the number of clock cycle will pass, but still it will not go to any other state, red or yellow. But if through some external combinational circuit, if external input X is applied, so if X is equal to 1, it's a external input applied to the system, then it will move from green to yellow for some period of time, let us say for 5 seconds. So till 5 seconds are over, again number of clock cycles will pass, but it will remain in the yellow state. And if another external input is applied, for say X is equal to 1 again is applied, it will move to the red one, and for next 120 seconds it will be in the red state. So there are 3 different states, and the circuit which is containing these 3 states, they are not allowed to move from one state to another unless and until external input is to be applied. So this kind of machine is called as a state machine. To understand it more clearly, we need to see a following diagram. Let us say there are 4 states, S0, S1, S2 and S3, which will be moved from either of the states depending upon the external input X. So let us say for X is equal to 0, the S0 system will remain in S0 for the input X is equal to 0. Whereas if X is equal to 1 is applied, it will move to the S1 state. For S1, if X is equal to 0 is applied, it will go to S3, and if X is equal to 1 is applied, it will remain in S1. For S2, if X is equal to 0 applied, it will go to system or state S1, and if X is equal to 1 is applied, it will go all the way through S0. And for system S3, if X is equal to 1 applied, it will again go to S1. This is how the state diagram is demonstrated for the external inputs X. Here you'll come to know one point, that we are not talking about the outputs. Why? Because when outputs are considered for the state machine, the output depend upon 2 conditions. The output is associated with states irrespective of the inputs, and the output associated with state machine dependent upon the inputs as well as the states. So as you see here, there are 4 states, so we require 2 state variables. So let us say A and B are the 2 state variables to represent S0, S1, S2 and S3, and they are represented as 0, 0, 0, 1, 1, 0 and 1, 1. Okay, we missed one point here. For S3, for X is equal to 0, it will go to S2. Okay, now all the states are complete.